Ask the Experts is a panel session that I've done now. We're in our 8th year, and it's typically a lot of fun. The last hour we had, I think it was pretty good hour we had.
Totally.
The mantra is that there's no rules, no, this is not pre-scripted. I have no prepared questions. The success of this is on the audience. So one ask I have as I go through my ordeal and introductions and whatnot is that we have one microphone directly in front of me, and it's all about you guys. You have to ask the questions, ask what's on your mind, what challenges you're having, questions about what's going on with cloud native apps and with perhaps what Nick is doing at Intel in the cloud unit, what Chad's doing with the Federation, what Vaughn's doing with Pure, and what he's seeing in the industry. Again, the questions are from you guys to us. So please start, don't be shy, start forming a line at the microphone, because as soon as I'm done, it's again on you. Otherwise,
and every year that we do this, it's always that weird moment of who's first. So
right.
Be bold, somebody.
Yeah, be bold, don't be shy.
Break the ice.
And as soon as there's one, we'll have 30 behind. So
there we go.
Great, thank you for starting to form with that. I'll kind of skip through. Let's do some quick introductions. So I'm Rick Scherer, I'm a principal engineer with EMC. VMware VCDX run a blog that's kind of been in flux right now because of work and twin boys at home, but it's VMware Tips. So on our panel, we have a great panel of industry titans.
So you're asking us a punch above our weight here, a little buddy.
So in all honesty, I think, and it's probably because of what I've been focused on lately, Kit for me is probably the highest of the titan because of the announcements that were made Monday, the focus of what's going on with cloud native applications. So for me, Kit's, I'm in awe of Kit right now on stage. So,
the bar is set way too high. Gotta lower it a bit.
So with that, just some quick introductions.
Great. So hey, it's great to see everyone here. Though this room is heavily weighted towards the doors, it's like I keep wanting to turn my head and look left. I'm Vaughn Stewart. I'm the chief evangelist at Pure Storage. It's great to see everybody, and it's my privilege to be joined on stage with these folks.
My name is Nicholas Weaver. I work for Intel. I do two things. I run a group called SDIX that works on prototyping, cloud software, cool stuff, and I run orchestration and scheduling. So scheduling cloud apps, scheduling VMs.
Cloud A, Cloud B.
Cloud letter, yes.
Yeah. Kit Colbert. I run the cloud native applications team at VMware.
Hi, everybody. I'm Chad Sakac. At SacacC on Twitter, and I author a blog, Virtual Geek. Day job, lead a passionate army of 4,000 nerd brothers and sisters in the field. Night job, work hard with my Federation brothers and sisters and partners at Intel, even competitors at Pure, try to move our industry forward.
Awesome. So again, I already talked about a few of the rules. Again, it's not about us on stage. It's about the gracious audience members that already formed a line to ask some questions. So thank you, and let's keep that line growing. We'll have roughly about 55 minutes to answer as many questions as we can and get through it. Informally, roughly about 60 seconds per participant for response. I'm not going to hold anyone directly to that, but I want to make sure that we get through everything.
That's called the
One thing I said in the last session, I'll repeat it, is, and I can speak for myself and hopefully I speak for everyone on stage, we're not shy, we're extremely humble in the positions that we hold and gracious to the communities for helping us get to where we are. So keep the conversation going. Follow us on Twitter, on LinkedIn, Facebook. If you see us in the halls, walk up and say hi. Don't be shy. I love meeting people and hearing about what they're doing and challenges and whatnot, especially if I can help get customers away from Pure and onto EMC products.
That was funny.
All right, with that.
George, you're using an all-flash array, aren't you?
Yes, I am. That's kind of actually why I wanted to stand up here, and
I did not set this up,
no,
dude.
but in all seriousness, this thing kind of started with you guys a couple of years back when you were at NetApp, and Pure actually taught me Flash is the future, and we're replacing everything with Flash. Unfortunately, we do a lot of business with EMC, so that's.
But at least you've adopted Flash. Your life is you can't tell me your life's not better on Flash than it was with disk.
I can't describe to you how much easy it is for me to walk into the office every day. I get to focus on new things. So with Pat Gelsinger's amazing speech yesterday, I thought that his 5 points were very awe-inspiring just as a human being, not as an IT nerd. But with you guys all up here on stage, we got EMC, we have Pure, two big flash vendors that have great flash arrays in my opinion. And then we have Intel. And I'm curious, with Pat's kind of looking 5-10 years in the future, and what you guys know, because you get to see cooler stuff than I get to see, where do you see Intel and storage and compute all coming together to go even faster? I know there's DSSD, which is face melting fast, and it's really cool. But in all seriousness, 5 or 10 years from now, what's compute, storage, network going to look like?
You just want to say we're all beholden to you and then just laugh?
So I'll start answering this, but I don't think it's possible to predict completely. There's some interesting things we look at. One is you look at some of the biggest cloud people in the world, like the Googles and the Facebooks and the Amazons, and some of them are using storage in very interesting ways, right? They look at storage as something that takes up half of a data center or an entire data center, right? And that's not something that really escapes out of those walls very much. And it's not something necessarily everybody in this room even needs. But there's interesting patterns that they've proven that I feel in the next 5 or 10 years we'll start to see those show up in vendors and in the ecosystem, ways of scaling out storage in different ways. I think we're still in a pretty good transitionary period going from classic enterprise arrays into like some of the new stuff EMC is going down the path on, and some of the stuff that maybe some of these groups are doing in secret possibly. Ultimately, though, I feel like all that is actually keyed into one extremely important thing, and Pat hinted at it. One of the biggest innovations happening right now is true automation in the data center, and that goes back to the machine learning and actually more into deep learning. If you go and open up a Google phone right now and use Google Photos, you can ask it, show me every picture of a beach I've ever had, right? And so I feel like the combination of machine learning, deep learning, the ability to start recognizing, a computer to recognize patterns and triggers and things, tied into scaled out storage, I think that's going to be revolutionary in the next 10 years.
So the amazing stuff that's at the tip of R&D and early stage venture funding, so EMC, VMware do a lot of early stage venture funding, so does Intel. I think that all of us agree that a big part of machine learning algorithms are going to be dependent on persistence that is memory. Like today, the bulk of the all-flash arrays store VMs, they store VDI images, they store OLTP, relational databases, that sort of stuff. It's a smoking fast machine learning algorithm that is going to iterate off of information really fast. You don't put it on an all-flash array. What you do is you store it on an in-memory fabric. And right now, there's a whole bunch of really interesting projects that exist out there, Spark and stuff around the Hadoop ecosystem. But there's other things coming too where people are innovating both in the software layer and the hardware layer. So high performance memory interconnect, weird things that are very esoteric that are, it would be wrong to call them NAND successors because they won't replace NAND, but they'll become a new member in the persistence hierarchy. I think within the next 5 to 10 years, we'll certainly see a lot of that stuff show up. But again, the thing that I think is the most awesome is how people leverage this stuff. And the way that they leverage it is increasingly using durable constructs and patterns that are declarative.
There's actually a really interesting aspect of that we're discovering on my team that does distributed computing, that there's these problems we've had in like super scale out, where the biggest problem was you couldn't persist these small things quick enough. And if you actually, all of a sudden, you can persist quick enough in small increments, like an atomic lock or a mutex, you actually end up getting these massive scale problems go away. So it's not just like these bigger patterns like machine learning and deep learning. It's literally like the way I write a simple application that takes orders could drastically change because the locks and who goes first. is going to this new thing that didn't exist before.
There's this really weird thing in computer science where like certain operations require a system lock, you know, at very low levels, and it's hidden inside code way deep down. So and it still exists, because the one thing that people don't understand is, I try to avoid the word storage because it brings up a visual of an array in someone's brain, right? Like, or a disk. I try to use the word persistence because there's actually this whole ecosystem of how information is persisted, you know, in totally different ways. In any case.
And it's going to change. It is.
Yeah, I think from a very pragmatic standpoint, and I agree with you guys, you know, when we start to look at challenges around big data and the volume at which data is being produced and how we want to leverage that data based off of machine learning, right? We need new constructs and we need better constructs than what we have today. I agree with that. But I don't think in 5 years all of you that you'll, you know, be out of the VMware space and all of a sudden be into the Hadoop space. Some of you will be, but not all of you. So I think when I look at a more shorter term, what could you expect near term? It's really interesting the trends that are going on in markets. So drop the vendors, products, or the terms, but you see this. We used to use this term, particularly in this audience, around, you know, the generalist, the IT generalist. You know, all the skill sets would merge, and I don't think we've seen that. But I do think you've seen a lot of effort to merge the capabilities of the server admin with the storage admin. Every next-gen storage platform is simpler than the predecessors of the legacy arrays. And they've got better plumbing into the ecosystems and into the application layer. And so, you know, I could be talking all-flash array, I could be talking Tintry, or I could be talking, you know, HCI, you know, hyperconverged, Nutanix, vSAN. They're all simpler than what than the world used to be. What I think is interesting is as we start to shift from our current fabrics over to things like PCIe and NVMe, and now we start to build out this fabric of nodes. Well, I think we're going to be turning the data center back into a large computer versus servers and storage in the traditional sense that we have. And when you look at some of the constructs like data center disaggregation, and you do go to the large scale web clients, you know, they're not using the same tools that we're building our data centers with today, right? They've fostered a new model, and these here's a rack of compute, here's a rack of all flash, right? And it's, you know, accessible on demand, but it's all one big mesh of basically a local computer. It's a big fabric.
Nick, I think we were trying to do some PR this week, but couldn't pull it off on that highly automated, disaggregated system.
No.
Shh, don't tell anyone.
We have all kinds of awesome things coming.
Thanks, guys.
Yep. The interesting, so you mentioned like PCIe and NVM technology, and I heard some really interesting things from Rob Pegler at Micron earlier about, you know, how silicon, they can't get it any smaller, so they're doing it 3D, right, to increase the capacities. Yes. Where I'm going with this is all this new great technology and faster and faster and faster, like in-memory speeds, typically not for virtual machine workloads though, right? It's going to be for cloud native type applications, right? You know, do we need my Oracle database to be
I would
faster?
I would disagree with that. So the problem with the storage industry is we like to tell you, you know, tangibles about the platforms like IOPS. And that, at the end of the day, is a sizing exercise. What's really been an interesting learning point around the adoption of solid-state memory, and so today it's NAND flash, whatever it may be tomorrow, has been in a couple of areas. So I'll take something very pragmatic before I extend from this my thought train here. So remember, for years ago, we'd be VDI, and how many IOPS is a power user, and how many IOPS is your call center user, right? We're doing all this. It was never about IOPS for success. It was about latency. It was the experience. And unfortunately, you know, you'd give a virtual desktop, you know, environment to a user, and you come back and say, it's unresponsive, I don't like it. Well, they were going home and comparing your virtual desktop experience to Candy Crush, right? That's the reality of the expectation. And so what have we learned is we've gone from faster and faster. It's not about IOPS, it's actually about latency. It's about raising the quality of the application. You put any app on flash, and what you tend to hear back from the users in the environment is, wow, did you upgrade the servers? Right? Everything's just more responsive. Whether the application can leverage using more I/O and take I/O bursts and complete more operations faster or handle changes in workload, that's a side benefit, but it's actually been latency that's been the big surprising factor. Add to it then the reduction in footprint and starting to look at storage, not dollar per gigabyte, but gigabyte per rack unit or watt per gigabyte is how the big thinkers are looking at how am I going to scale, you know, the ability to accumulate and store massive amounts of data in my current physical data centers. And it's this retrofit from spinning, rotating media to solid state.
Yeah, I mean, I would say the applicability is definitely beyond, just cloud-native apps to sort of any sort of app. One thing that we're doing at VMware is looking at how NVM technology changes hypervisor design, right? What can we do differently and more efficiently? And we have a number of research projects looking at that. So I really think it changes everything to the points that were made here. It's like there's fundamental assumptions about the system that will change because of this. And that means you can really take a much different design philosophy.
Yeah, you eliminate latency in terms of I/O weight, whether it's a database or a hypervisor, and you can actually run more workload on less hardware. Mm-hmm. Today we compensate through parallelism because we're waiting on I/O.
Thanks.
So this is a little bit more low level, but I was just wondering what your input would be on. So there's probably lots of people who want to be bleeding edge, newest possible vSphere version, but we still have some people sort of waiting a little bit, trying to see what features would you guys suggest to these people that they should use to convince the organization to upgrade to vSphere 6?
End-to-end T10 unmap from guests through to the storage array. Cut your storage footprint in half tomorrow.
I'd obviously point to the increasing scale and use cases of VMs expanding, number one, right? But the bigger thing I would point to is that the SDDC stack actually matured. So not just vSphere, but the SDDC stack. I'd say that vRealize 6.2 and vSAN 6.1, man, is unbelievable compared with vSAN 1, right? So just thinking about Charles and team and how they're going to keep iterating on that, and Christos and crew. I would not make it about vSphere itself. I'd actually make it around the totality of NSX, of vRealize, of vSAN and the ecosystem.
Yeah. I mean, no, I think that's the right answer. I mean, in terms of specific things, one thing I think is really interesting in vSphere 6 is this little feature called Instant Clone, right, which was Project Fargo from last year. And so what that does is basically rapidly provisions you a new VM, and it's under a second, the VM's fully powered on, ready to go. And the reason this is important is not so much just it by itself, but kind of how we're using it. So there's two different ways in which we're going to use it. So the first of which is what we talked about on stage a couple of days ago in the keynote around this whole just enough virtualization, right? We can make one container per VM work because of the efficiency and the speed at which we can provision VMs. And like the idea there is really interesting, right? Like we're talking about a different form of virtualization than and VM management than we traditionally have done. Traditionally, you provision a VM, you install the OS, you install the app, you patch it, you update it. If it falls over, then you fix it, right? And it lasts for months or years, like that VM's out there. These VMs, these just enough VMs are different, right? They're provisioned on the fly, whatever container is needed, and they live for only as long as the container runs for, which might be minutes, maybe hours, maybe days, probably not much longer. And so it's interesting because this is not, this VM is not being necessarily explicitly managed, but instead is built automatically by vSphere for you in the form that you need. It's got the right data in, and we dynamically inject our hot add VMDKs and so forth. So the other form this is taking place is inside of end-user computing on the VDI side. There's lots of problems and challenges in the VDI space, and I think the technology's come a long way. Solid state's been huge to help with performance there. But overall, over time, what we started looking at it is like, why are we maintaining and managing this like giant VM for someone, persistent for like months or years, right? What we can do now is if the VM is cheap to create, that means all we need to do is save the metadata about that VM and recreate the VM on the fly. So this is what we announced last year called just-in-time desktops, right? So rather than having a persistent VM that is a VM with a certain name, it stays around, and whenever you log in, it's kind of there. What we can do instead is whenever you log in, we will reconstruct a VM to look exactly like your VM on the fly. When you log out, we kill that VM. We of course save persistent state and so forth, but instead of being like a 40 gigabyte disk, you use like 500 megabytes of actual stuff that you care about, right? So I think this is kind of like, the instant clone feature is really interesting because what it allows us to do is to go to this mode now where VM creation is so cheap, we can make that the constant, right? As we continually create stuff on the fly and reconstruct the identity essentially of that VM. So that's one thing that's really exciting to me because I think it brings great deals of efficiency and automation and solves a lot of management complexity.
I kind of made the flippant comment early on, but seriously, there's some great storage enhancements in vSphere 6. Ahead of vvols, now support for end-to-end T10 unmap from guests through to the storage array.
Yep.
We did some analysis years ago when unmap became available in like vSphere 5.1 timeframe at the data store level, and the analysis suggested that while you could reclaim space at the data store level, the bulk of the data that was deleted that was available for reclamation was existing inside the guests. And because the storage arrays had no visibility to that or no understanding, you in turn, are hosting environments that are full of invalid data blocks. So by moving to vSphere 6, and you have to take the latest version of the virtual machine format, your Windows virtual machines, because they communicate unmap over a SCSI2 command, will start passing unmap calls through the hypervisor. And I'm not trying to be hyperbolic here. I think for a fair amount of customers, your storage footprint will reduce anywhere from 20 to 50%. Particularly if it's an aged virtual server environment. Add to that, in the SIOC space, some enhancements around what a lot of people would classify as quality of service. Now the ability to set reservations or minimum IOP reservations, along with limits and prioritization. That's a pretty robust software stack that just works on any storage platform.
The thing that I've, Vaughn and I, over the last few years, we presented like a storage kind of ins and outs session. What's been just shocking to me is actually how few customers use like SIOC, even through vSphere, original 5.0 and then 5.5 releases, and storage DRS, like which were mature and now we're even more mature. Obviously the unmap keeps improving. I still think there's a few little gaps to fill out, but you're right, all of those things are incrementally better. I gotta be honest with you, I'm always shocked to find out how few people actually use the stuff that vSphere does, even with their current, their current code base.
Yeah, and just for clarification, your Linux VMs likely won't see any benefit from vSphere 6 with unmap because most Linux kernels pass a SCSI4 level command, and that's currently not understood by the vSphere.
You can do it manually. There's various techniques to do it, but it kind of sucks.
Yeah. But look, getting the Windows VMs is a fantastic start.
Yeah.
Thank you, guys.
Yep.
My name's Chris Eckert, and
Hey, Chris.
I am curious about something. Given that there's always been several aisles, rows, sometimes floors, or even buildings between the systems people and the network engineers. And there has always been called network engineers because obviously the network's broken when an app slows down, and then there's that push back and forth trying to find out what's really going on. Over on that floor right now, you have companies like Viavi and NetScout, Riverbed, all who have released packet capture engines to run in virtual machines. Mm-hmm. Do you see this as, do you see the outcome of this being more that the systems people will now be able to take on the packet, looking at a view from the wire, or do you see this as being the network engineers are now going to need access into the systems?
So my experience over the last few years has been that the storage ecosystem within our customers and the finger pointing that exists between the VMware admin and the storage admin, eventually that started to become so horrific, right? That eventually people realized that virtualization had to break down those walls. The technology partially made that possible. vCenter plugins phase 1, VAI phase 2, vVols now, blah, 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 blah. But it also actually started making the good storage teams at big customers where it's two different roles on two different floors and two different buildings, to your point, that kind of started to come together a little bit, right? Not full-blown cloud ops one team, but got better. I think that basically the networking domain, at least in my experience, is just lagging a little bit, and now it's being forced. It's being forced by two functions, by SDN control, so the ideas expressed by the NSX controller saying, hey, it's possible to create overlays that are integrated, the functions starting to become dispersed, the VDS becoming stronger and stronger and stronger, and by network function virtualization, where network functions now run as virtual machines. That creates like inevitability of tension, right? Where they start to fight, and the trick though is like the whole IT operational model of like silos of excellence separated by SLA boundaries, and SLA is code language for no, it's you, right? That is totally busted, number one, and in the world of truly declarative app and infrastructure in cloud native app land, it is not only busted, it's actually totally stupid and doesn't exist, right? And that's creating some cultural shift back where that boundary is breaking. But I don't think that the answer is that the system admin or VMware admin is going to be the network admin, or that the network admin is going to be the VMware admin. It's actually, I think those roles become all munged up.
Well, I think it's also like, I agree, and I think it's, to some degree, it's like, the creation of the network should just be automatic to some. It's like kind of like what I was talking about with Instant Clone. We just start creating VMs for you now and take care of that. And like, it shouldn't be so much job. It should just be taken care of by knowledge of what the application needs and how its topology is built out. That should inform the network about what it needs to be doing. And so that's the power of network virtualization. I think it's going to be coming, and it's going to create a lot of tension, as Chad mentions, within the organization. But I think his point is right, that these roles will evolve naturally. And what you'll see is that folks will be doing higher value stuff. They won't be kind of doing the manual configuration and setup. That stuff will all now be fully automated because the information is there, either declaratively or as part of the application topology or whatever it is, that the network virtualization piece can take and run with. So, yeah.
On the path to Nirvana, there's going to be a lot of bar fights.
So I got
And
a
not
question.
so much singing Kumbaya together. In other
I got a
words.
question for the audience. How many people here have a trunk port plugged into an ESXi server? Raise your hand. Yeah, back in my first VMworld, that was a big deal.
Yeah.
Like, oh my gosh, we're gonna give them access to VLANs? Oh no, oh no. the network admins are gonna throw a fit, right? So we moved past that. And I look at, so I'm one of those guys who's done automation, is big into it. I'm still a firm believer that every single operational role, whether you're storage, whether you're network, whether you're VI, whatever you are, application, the intent here is as we evolve and get better at running stuff, our tools change. First of all, like the mechanic nowadays has a completely set of different tools than my grandfather had back when he was fixing World War II vehicles, right? And so as the technology improves, we actually get to manage more things. And so like the tools that SDN brings allows the network people to provide a better networking service that doesn't need the babysitting and the log catching and all those interactive, non-productive things, really honestly, they've been doing. That means they can only manage so many switches. And now if we have better tools, they can manage huge farms of networking in a much more powerful way. And that's what Google's been doing, right? And so I think that's the intention here. It's not that there's this fight over this real estate, it's that both sides actually benefit, and they're able to manage more things, have more power on their own.
But there will be a fight over the real estate.
Totally. That's the thing that's frustrating.
challenge.
You can see the answer. You can see where you are. The role is critical. It's going to actually be happier for everybody on the other side, but there's going to be a lot of snit fits and bar fights, and it's not just amongst the humans, it's amongst the vendor ecosystem, which kind of sucks.
Yeah.
And I would add in here, I think if you go back 5, 6, 7, 8 years ago, I think we looked at the storage teams as probably being the most, or the least likely to take on new technologies, to be the most conservative. But we've actually seen them really make a lot of movement. In the interim, don't even skip ahead to where we're at today with the technologies. Just look at unified fabric. I mean, that's still struggling to get off the ground because you just can't get fiber channel and Ethernet guys to get on the same page. So, I'm not trying to throw networking guys under the bus by any means. Obviously, they've got a domain and a skill set that is very valuable to us to be able to communicate. But I think the storage layer has been much more agile in the last 6 years than maybe the networking layer. So it'll be interesting to see how this moves forward.
Network has not been disrupted enough. Just as a Sweeping statement.
There's also a more general.
Now I'm terrified.
But there's also a more general challenge, I think, as well. I mean, when you saw, like, you know, the thing with virtualization when it first came in is that it didn't really require much process change, right? I mean, it took a process, you know, of procuring a physical server from like 6 months down to like, you know, a couple of minutes or whatever it is. But it didn't fundamentally change the organization or process. And now what we're seeing is virtualization is great and very valuable, but some of these things that like network virtualization and, you know, really even self-service kind of private cloud types of models, those things are extremely powerful in helping to drive business agility, right? And good business outcomes. But those are the things, it's not just a technology problem, that gets to the people, role, you know, organization, and those are the big challenges. And I think that's the thing that has, you know, probably slowed the adoption of this, right? Because it is, and it's not that people are necessarily malicious per se against these things, but it's like they know how they got a system that works, that does a thing, and really it takes, you know, frankly heroic efforts usually from individuals within an organization to be able to, you know, get the buy-in, get the leadership approval to push these things through.
Good time to be a hero, though.
Yeah, no, it is. I mean,
Notice
this is the opportunity.
Some network engineers here. I mean, things have changed.
Yeah. Oh, so I didn't mean to. Yeah, fair enough.
Welcome. Welcome.
So a couple things I wanted to add. One, there was always this talk, like and EMC and the Federation were really strong behind this marketing message of silos being destroyed, right? And it's just one big open happy family. When the reality is, there's still going to be needs for SMEs in each one of those silos. You know, the silos now just have intercom boxes between, right, between them, right, and tighter integration. But I think, you know, your question itself was, you know, we talk about these network functions that are now running as virtual appliances. In essence, it's just taking the code that were, you know, on physical appliances and just running them as virtual machines. You know, and who owns that now because it's a VM. In kind of my opinion, the VMware infrastructure guy, you know, he's just a platform now for that service to run on top of, which means the network guy could still be the one in charge of that application, right? It's just now an application running on top of a VM.
It always was an application. You just came canned on a piece of hardware.
Hardwired, yeah.
Just had a whole bunch of wires in between.
Well, I think the other thing that's kind of interesting that I was noticing, if you look at the Solutions Exchange, I mean, you know, like folks like Palo Alto Networks, they have a monstrous booth, like right in the middle. And it's kind of interesting that these networking companies are coming here. That's kind of telling about the changing roles and nature of the situation.
There's also a lot of telecoms that started announcing, I'm not going to drop names because I don't mess up their press releases, announcing that they're looking for completely redoing the way, I mean, massive ones, the way they do their entire routing and switching backplane, like the biggest networks in the world, and they're saying we're going to completely go down the network function virtualization route. Because for us, it's much more agile to have smaller units of this in microservice form and have them scheduled in an automatic way and just design and have it react to the network. And so I think that'll also be a big thing. Is it'll start up there, but over time that'll drift down into solutions that vendors will come to the fore with. Right. So the pattern will emerge.
Thank you.
Thank you.
That was most of my question, but I guess to add on to that, what is the one thing?
He's been patiently standing there the whole time.
So for organizations looking to go from the traditional to the software-defined data center, I mean, what's like the one thing you need to get right, or one or two things that, you know, you can't really ever make that leap if you don't?
It's
culture
people
of blame.
plus, it's not technology. Technology comes second, right? It's like the organization, it's the culture. I mean, like, just real quick, you know, the way in this whole cloud native space is, you know, this concept of Devops, right? It's good to spend time understanding what that's all about, because it's not about technology, it's about people and process. And what it's really about is the fact there's a bigger picture here, right? You know, as we see businesses try to differentiate more and more via software, IT becomes a huge differentiator for that business, right? Well, high-performing IT organizations can get new technologies to market 200 times faster than lower performing ones. And you think about that, you know, if you two competitors, one with a high performing IT, one with low performing, these guys are going to get 200 times faster, you know, to market. So you can imagine who's going to win, right? So when you think about that big picture, it's kind of like how do you go from idea to running code in production, and how do you optimize that whole thing? And I think it's really everyone coming together saying, okay, I've got my little silo, I'm doing my thing, but I should be always having that bigger picture in mind, right? How am I helping that bigger picture move forward, move faster, evolve? Too often you get stuck in the silo, you put processes around it because you want to maintain control, and you lose sight of that bigger picture. So I think that's kind of the key thing, is that everyone's agreed upon and aligned upon that bigger picture.
It's very cliche at this point, but I still find a lot of people haven't read it. The Phoenix Project by Gene Kim.
Great book.
Great book.
Yep.
And it's an amalgam of like 50 real customers that they've turned into a hypothetical story. It's a light, easy read. You can read it on the flight back if you're flying wherever. Download it to whatever book e-reader you use. But the core essence, if you distill in the story, is a cultural change.
Yeah.
Not even that it's not that the network admin disappeared or the storage, but they moved from a psychology and a culture that looked like this to a psychology and a culture that looks more horizontal, right? And again, you can actually, it's a good time for a hero, right? Because basically you're rallying people around the bigger theme. The bigger theme is whatever matters to the company. The company actually doesn't, whoever you work for, doesn't actually care about VMware or networking or storage, right? Like, so there is, however, some bigger rallying point for whatever industry you work for. And if you rally everybody around that bigger theme, you can get a cultural transformation.
I talk about all the time, technology, and forgive me if you heard me say this because I'll repeat it, technology by itself has absolutely no value whatsoever. Technology is just a tool. As technologists, we're completely worthless unless some kind of business or human value emerges from that. We make it better and faster. I love the cultural reference because I always, with my teams, when we do Agile stuff, I always remind them that ultimately we're all in the same boat. And it's not just the team I'm talking to, but literally every single person you work with in the same company is in the same boat. We sink or swim together, right? I think culturally that's a real good thing to grasp, is that across lines, we're as a group, we actually make this company successful or not with that technology. And so being able to cross the lines and communicate, be able to get on the same page, give each other credit is a huge piece that I see comes up and is missing. And actually the Phoenix Project covers this. But it's cultural, and it's not necessarily managerial cultural. It's not like your VP has to set it. Oftentimes the real innovation comes out of the engineers cooperating and communicating with each other. The successes I've seen almost always emerge from that, and they influence their leadership in that way.
Cool. That's an interesting question.
Yeah, that's a good question.
Yeah, good question.
And talking about the futurescape, you mentioned Google, Amazon, some of these bigger clouds are discovering new patterns. You talked about new technologies that are allowing hyperscale, massive scale. Things like Exchange administrators are going away because of Office 365. Now VirtuStream is saying SAP can go to the cloud. So if all pets and cattle can all end up in the cloud, is the private cloud going to start evaporating?
So, no. Just a declarative no. And I've been trying to figure out how to communicate this, and I'm doing it badly, and I'm probably going to do it badly right now. Okay? If you imagine a three-dimensional X, Y, Z graph, right? The choice of on-prem or off-prem is one axis. The choice of CapEx or OpEx is another axis. And the choice of do you run it or does somebody else run it is kind of the third axis. The choice of on-prem or off-prem is primarily governed by data gravity. Compute tends to live wherever the data against which it is computing happens to be. So if the data was born in the public cloud, the compute is likely to be co-resident. If the massive data is on-premise, the compute is likely to be co-resident because data is heavy and difficult to move, right? There's exceptions and blah, but as a general, that's one. The second one is governance. Governance, not security, because public and private clouds can be both super secure, and people who FUD the public cloud is not secure, I think that's wrong. But there are rules, governance, compliance, things that govern healthcare, finance, FinSec, every industry, right? That's the thing that governs the on-prem and off-prem thing for the most part. The CapEx and OpEx thing, people conflate with on and off-prem. They're not related. Whether something is better off as capital or whether it's better off as operational expense has to do with, does your workload look like this? Netflix. Does it look like this? I have no idea. I'm trying something cool. It could. Those gear towards OpEx is better. Workloads that tend to look like this, like hover at a steady state, tend to favor CapEx, and you can do those on or off-prem. And then you run it, someone else runs it, is purely do you view it as a competency for you, yes or no? Now, the whole of IT historically has all been clustered around on-prem, CapEx, you run it. All that's happening is that now there's new options where you can be anywhere for a given workload on all of those axes.
Question for you. What do you drive?
An SUV.
An SUV. So why don't you ride the bus?
Doesn't go where I want it to go.
Thank you. That's public cloud versus private cloud. No matter what you do, any kind of public
Well,
cloud.
that's better. I'm going to do it your way.
No matter what you build, and this happens in software quite a lot, you can build something to be so generic you think it works for all use cases. Then someone will come along and they will build something just a little bit special for that person, and they'll choose that because it works for them in a better way. Ultimately, there's no way to build a single public cloud that can make everyone happy. And there will be great cases where we'll have commonality, but then what happens is, people forget this a lot, that all of a sudden if I'm using Amazon and then somebody says, oh, I figured out what you were doing and I can give you a private cloud that's cheaper and runs that better, then they'll switch, right? And so even though we have these public clouds leading in a lot of ways, private cloud has had a lot of extremely great innovations, and even at Intel, we're really exploring how do we get these things tuned, how do we get some of the things the public cloud has been doing from a scheduling standpoint, and democratize it is a great word we use. Like literally, we're going to take the stuff Google's doing and say, here, everybody should be able to do this. That means you could specialize to have very dense, powerful private clouds that work very well for your purposes at a great price.
There's one thing that press and analysts do that really pisses me off, which is that they try to trivialize things and they get it totally wrong. Amazon and Google's advantage isn't their scale. Everyone thinks that it's their scale that has made them super awesome. And it's actually not their scale. In fact, now that their economics are public, now that Amazon and Azure are sharing their economic structures, you can see that they're wildly profitable businesses, which means that it's not razor-thin margins that they've able to do because of their hyperscale. What their hyperscale has allowed them to do is hyper-automatize around what they're really good at, right? And be able to do it at very large scale. Therefore, you can build all sorts of different cloud structures that in many cases can smoke the hyperscale guys on economics. It's not about hyperscale is cheaper.
Right. Let me give you one more example. Let's go back 15 years or so. And hopefully most of you in this room can go back that far. I don't think I can.
We're not speaking to a high school audience.
Hold on. We can go back that far. Let's 12 years. But at one point in time, I mean, how many people, what was the percentage of Windows servers that ran web, IIS workloads as far as web? It was massive, right? Everybody thought, man, there's just no way that anyone's ever going to build a better web server than Microsoft does, and it's all going to be proprietary. Now look at it now. Linux and open operating systems are something we just take for granted. I can turn this on, it's going to work, and it's going to run. I look at public cloud the same way. Right now, we look at these big ones that have proven some stuff. All they've proven is that it's possible. We're following behind it, and we should be able to catch up to this and do some really cool stuff with it.
I mean, we're also talking with a number of startups, and of course they largely use Amazon because of the point you made, Chad, that they don't know what their business looks like. It might explode tomorrow and go gangbusters or whatever. So what they're seeing though as they're starting to mature is that these guys are spending tens of millions of dollars a year at Amazon. They actually can calculate it out per developer, and they know they can do private cloud cheaper. And so now they're starting to invest in these private cloud, this building out of a private cloud. So there's a number of folks that we're talking to that are doing that. And so it's a pretty common theme, and something I don't know if it was us or someone else that did a survey of startups. It's actually pretty common for them to see that, right? Is that they get to a certain point in their growth where some of the traffic starts to become more predictable and so forth, and then they're starting to look back at private cloud again.
And then what happens is, because press and analysts sometimes are looking for the simple story, the eyeball catcher, they go, but look at Netflix. And the answer is Netflix will always be very heavily dependent on the public cloud because they're a workload that looks like this. If you're a Salesforce.com, your workload actually looks a lot more like this. So SaaS startup, start small, not sure, scale up, elasticity, super good, awesome, great, and now I'm actually big, very often, not always, because sometimes they're like a Netflix, up and down, up and down, up and down. And no one should have heartburn, in my opinion, about this public versus private thing. Like we should have no heartburn. We should be cool as cool cucumbers on it. What we should get mad at are people who try to oversimplify things because they can't, as humans, retain two opposing ideas in their brain at the same time.
Yeah, I think when you look at the web, the demographics of the web, they fall into two broad buckets. Now, this isn't a be-all, end-all statement, but you have small businesses, startups, but also just established small businesses that decide, I don't want a data center, I can't afford a data center, I'm not going to launch with one. And they go in the cloud, and that makes perfect sense. And I'll come back to that in a moment. But when you look in the enterprise side, by and large, the majority of the adoption on the enterprise side is shadow IT. It's development teams wanting agility. And unfortunately, most of us in this room have gotten our private cloud to a certain point in time where it still requires the end user to make a ticket, to wait for a service to be provided to them. We haven't, for whatever reason it is, trust, chargeback models, whatever it is, we haven't
the whole
taken
process and, you know.
Yeah, that final step to just let our users punch in their department code and receive services. Maybe that's a technology gap, maybe it's a business process gap, but that's why they go to Amazon, that's why they go out the back door. Coming back around on the small businesses, and I completely agree with the statements that were said earlier on stage about the predictability and workload. If you're going to do a lot of transaction and you're going to persist, you're going to end up with a bill that's going to surprise you. And so one of our customers that started me looking into this was Skull Candy. Skull Candy, headphones, right? Nice, colorful, accessories for your mobile devices. Great products, great customer. They were growing rapidly and they were all on AWS. And then they got to a point in time where the bill was hundreds of thousands of dollars per month. And they built an internal private cloud, their first one ever, and the ROI was 5 months. Right? But starting in the cloud is what it took to get the business started. And so that was a logical step. But I started looking, and you can Google this. You can start to look for stories because they don't get the headlines of the companies who came back out of the cloud. Yeah. And what it tends to be is if you're going to transact and you're going to persist, you're probably going to not have the low price point that you expect to have. And it doesn't make any of these right or wrong. You were talking about Exchange, right? That's more of a software as a service offering. And this it's in some ways an adjunct to what Nick was talking about automating at scale. If you have finite IT resources in your organization, if moving the infrastructure of hosting Exchange goes from on-premise to off-premise, you'll still have to take care of users and mailbox and accounts. But maybe you can lighten some of your load by letting Microsoft take care of the rest of the infrastructure.
And being that I'm Intel, I can tell you that private cloud is not dead, it's not dying. Things are shifting around, things are changing, but there's still people, there's a huge percentage, you'd be surprised how many people still run bare metal. Don't even use virtualization. It's crazy.
Thanks.
Yep. I think the technical term is cray-cray.
Cray-cray. Well, that's my 12-year-old daughter tells me.
So I'm with NVIDIA, and we run bare metal on a lot of our stuff. So my question, we've talked a lot about software-defined data centers. We've talked about automation. And we talked about 15 years ago. 15 years ago, I remember there was a computer where I could slide more memory in, more CPU in, and it would notice it, Sunfire from Sun, and it would notice it, and it would just add it, and it would just work. And my question is, when are we going to be able to, from a software standpoint, say, I've got, I can see, and from an automation standpoint, say, I can see the load on this VM is higher. It's been higher for, pick your trigger point, 15 minutes, 30 minutes, an hour. We need to add more CPU to that. Or it's thrashing. We need to add more memory to that and be able to do that on the fly so that we don't have to wait and go through that reboot cycle, because that's silly.
So first things first, you guys make awesome graphics cards.
Thank you.
I've got a new 980.
All we ask is buy some more.
So I've got a triple SLI 980 that powers my Oculus rig at home, man, and it is sweet.
Thank you.
So thank you. Thank you. And the Sunray thing, man, and Sunfire and Sun in general, so many great things.
Heavy things.
So ahead of their time, and such a terrible story of finality.
Damn you, Larry, damn you.
Yeah, so that we acquired a company, man, this is a weird aside, but DSSD that had a lot of former Sun guys. And they actually left one of the walls in the building that they moved into that was an old Sun building, the purple Sun color, as like a reminder to themselves of, you could be so good and then just not quite get it right in some form. By the way, the thing that you're describing of basically being able to detect and then modify, so through some declarative model of what's needed versus what is available, actually isn't some future thing. It exists today in the world of these weird new elastic apps, and it's not done necessarily in the individual container. It's done in the elasticity of the microservice, right? So you grow or shrink the service, which is a construct, right? Rather than making a single one of them bigger or smaller. Now,
Well, that's great, but does Windows know?
yeah, well, so first things first, Windows generally is not the base OS in those cases.
Right.
Now, I do happen to know, although Kit will know far more than I do, that there are lots of interesting R&D projects, within VMware that are looking at, can you use analytics to auto tweak and tune things for these non-weird new elastic cloud native apps?
Well, I think there's a number of parts to that question. So let's talk about the mechanism first. So the mechanism is this question of hot add. So we absolutely support hot add today, right? CPU, disks, memory, all that stuff. Windows sees. I mean, you have to write the right, I don't know which operating system version of Windows, but the more modern ones will be able to see it and recognize it. But then there's the challenge of the application as well. Like, is the application going to be able to take advantage of that additional memory capacity or CPU capacity? CPU capacity probably would. Memory capacity, it depends on the application, right? Some apps start up, the Java heap size is a certain size based on the memory at startup time, and now we've added more memory later.
Yeah.
So so there's some of those questions to work through, and that's a very application-specific thing. Okay, so assume that can be fixed some way. Either you can.
It's just software, right?
Well, yeah, it's all a matter of programming, right? So, so assume the mechanism's there. But generally speaking, yes, you can hot add and make it bigger. Now the question is then the management or the intelligence as to when to execute that hot add. And so there what you're looking at is a number of things. You're looking at instrumentation to collect performance data. You got to understand the right sort of KPIs. Again, it's going to be somewhat application specific, but we can kind of look at memory and CPU generally speaking and see when it's starting to saturate and kind of make some inferences based on that. So we do have a number of projects we're working on, research projects looking at that to be able to either, as we said, provision more VMs of that application, more instances, or actually size up individual ones. And so a lot of this stuff is very close to being there in both, or in vRealize operations, right? We have both performance management, capacity management, algorithms. And so really it's just a question, because the other question is, what's the SLA, right? If you get like a 3-second spike, is it worth adding a bunch more memory?
Right.
Or does it have to be a certain amount of time? And how long will that last? Well, if it'll only last for 45 seconds, and at 40 seconds you make it bigger, then it goes. So there's all these like really specific wormholes or rat holes you can get into.
If it was easy, of course, we'd already have it, right?
Yeah.
So at Intel, we have a really interesting, my job is literally orchestration and scheduling. Like, this problem is part of my domain at Intel. And so we have a really interesting theory at this, because we kind of backed up and said, what are we trying to achieve? Like, what is the pattern? Yeah. And then we're actually attacking each section of that pattern and saying, how do we make this, what is the path to make this easier? And so for us, the pattern is this idea of the watcher, the decider, and the actor. And so the watcher is the thing that literally has the ability to see what's going on. So in any OS, at any level, any platform, can actually surface up what's happening. So this workload is suffering. So that can be an application level metric, or it can be cache is hit too much or flushing too much or something, right? It can be multiple different details. It can be both at the same time. The idea that you could actually expose the data, and more than that, you can actually consume it. So it's not this huge problem to go get through that data. The second piece is the decider. It's the thing that you can actually feed that data to and be able to set policies or rules or have it recognize there's something wrong here and I need to change it. It makes a decision based on that. That decision isn't necessarily a human being making that decision. It's a system that can make that for you. And that goes back to scheduling. And then finally, there's the idea of the actor. And the actor is the thing that actually has the control through your operating system, whether it's the hot add piece or linking. That actually has the ability to act on that decision to do it. And then our idea on this is that actually feeds back to the watcher when the decision's made in this kind of like virtuous cycle. Some people refer to this in the military as the OTA loop also. The idea that you can have a system that can actually, with some inputs and outside policy setting, can actually watch, make reactions, shut things down, do a hot add, change things around, move stuff. If you look at some of the projects like Mesosphere has with Mesos, Kubernetes, and some of these other ones that come out of the container space that are emulating Google's model of doing this, because Google's doing this now. A lot of this stuff is starting to democratize out as patterns. We still got a long way to go, but we're getting to a point now where it's a concept that's actually people are grokking outside of the big shops.
And just to be, I think, maybe a little bit of clarity on this, right? The problem domain in the monolithic app space, where Windows and Java heaps are prevalent, is much harder than in the model where you have got a microservice-oriented design of the application. It's not that, it's actually the same cycle of the watcher, decider, but it is a harder problem in one domain than it is in the other.
I actually disagree just a little bit, because ultimately, who here has used Puppet or Chef? Right? So we've been using this to change some attributes, because we don't want to have to push so many buttons, right? There's like 100 knobs. So I just say, can I say what I want the board to look like, and it changes whatever knobs are wrong. So we already moved to a declarative model.
Yeah, but does it reboot it after?
Which it could, though.
Right,
It
I know,
does.
but that's the thing that you don't want, right? You don't want to have to reboot. Every time you have to reboot, you've pissed off someone, if it's
Nick.
a person,
Absolutely.
or you've taken the
Right.
app down,
And this
right?
goes back to the actor model. So the actor model is literally like, the ideal scenario for you for this would be, give me a non-disruptive ability to reboot this.
Yeah.
I think we were actually saying the same thing. I wasn't saying it's actually the same theory of operation. It's implemented differently, and depending on the application architectural model,
Right.
your vehicle to have elasticity in one case is relatively easy-ish, and in the other one it's relatively hard-ish.
Well, the reason microservices even exist right now is because of those newer constructs.
Yep.
You build your application so it can be killed, because it actually makes things easier over here at the other end. But I talk about this a lot. This over here is awesome, looks beautiful, it's shiny, but everybody else is over here, and they need to have a path over here. You can't just jump over, right? And a lot of this stuff's really important. I think it's really valuable to bring up, because a lot of the vendors and people in our space need to know, like, that sounds awesome, but you have to give me this, otherwise it's not really useful to me.
Thanks, guys.
Yep. Cool.
Good conversation.
And again, thanks for that graphics card. Makes me happy on the weekends. Yeah.
All right, we're about wrapping up the hour, so I think this will be our conveniently last question.
Dun, 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 Speed round.
Okay, and I think mine's a quick one. So I have a question on the VMware storage stack. Alongside of all the phenomenal innovation and configuration maximum improvements over the past 10 years, there's been a spec that really hasn't changed at all.
Let me guess, maximum LUN count.
You're close. I can still have just a maximum of 4 virtual SCSI adapters per VM, and hence a maximum of 60 disks per VM. And a decade ago, I thought, well, who cares? I would never hit that. And now it's becoming a real problem. And there's been talk online about VMware possibly rewriting that storage stack. I think something having to do with SCSI 2 emulation. But that's been kind of blogged for years and hasn't really gone anywhere. So I wanted to find out from maybe Kit, or you folks that collaborate with VMware, is that something that's going on behind the scenes as far as a rewrite on the storage stack? And then also from maybe EMC's perspective or Pure, does that SCSI 2 emulation or whatever the holdup is there, does that kind of tie your hands for innovation for some of the things that you're trying to do?
Yeah, I mean, you might have better visibility into some of it than me, but I think I've heard a number of conversations about this. Has actually come up not infrequently, I would say, as a request, to address. And I don't know the exact status of us working on it, but I do know that it's just coming up more and more frequently, which means there's going to be probably more visibility on it.
This is one where literally, if you went and had Vaughn and I, and Vaughn in your old gig in the NetApp days, and if you had all the storage vendors added up here, we'd go. The one feature request that we keep asking is to increase the maximum LUN counts and the vSCSI adapter and virtual disk count, right? And it's so far it doesn't make it to the top of the heap. And without look, I'm not going to commit on stage to VMware's roadmap, right? It's currently not scheduled to be in the next major release to hit that specific problem. The reason it doesn't bubble to the top is because it's a very painful problem for a relatively small set of workloads. Right, so you know what I mean? Like you've got some monster Oracle rack host that you're trying to deploy, or some monstrous thing. Very often it comes up through people trying to solve problems in kind of silly-ish ways. you know, where they're trying to build like some crazy NAS stack inside VMs and scale it out crazy horizontally, when you'd be like, why don't you just use a good NAS stack outside the VMs? You know what I mean? But the problem is the pain is acute, but infrequent.
Yeah, I mean, I think in terms of stifling innovation, I mean, the only thing I know, I've heard around this one myself, is I know that the app volumes team has hit some challenges with that limit, right? Just because of the way they work, they actually connect a lot of VMDKs, in some cases to a VM, to dynamically inject that data. And so on occasion, they'll hit that limit. So that's one example I've heard where they'd like to have that.
There is, however, a ton of work going on in the vSCSI stack for the first time in a long time. So that part of the code base has been pretty static for a really long time. There's a lot of stuff going on around I/O filter catching. So there's a new Vsphere API program that is just starting up around that. And that's a good avenue for us to go and say, like, you know, hey, this is a chunk of code that's really mature, it's really good. Maybe it's a time to take a kick at the can.
Yeah, it's actually following up on Chad's point, so not just the vSCSI stack, but the entire I/O stack, I think, was acknowledged by VMware Engineering about a year or two back, that with the general knowledge in the room was, you know, the overhead, performance overhead of the hypervisor was maybe 1-2 percentage points, and everyone went, that's enough for me to take all the benefits of virtualization. But what they were noticing when customers were adopting Flash is that they actually recalculated the overhead to be in 40%, that it was masked through latency. And, you know, I know this is a storage piece, right? So I'm a little focused here like a dog with a bone on storage, but, you know, the comment back was, if we start to build the next generation of the storage stack and we write it for memory-based devices, think about all the other problems up in the stack where you start to get the vSCSI limits that we can now address. So again, I can't speak to the roadmap or make any promises, but there's a core underwriting. When, you know, you've gone how many years with this core kernel?
Yeah.
You're having the I/O stack rewritten for memory devices? This is fantastic.
Thank you.
And you know what? If you want more information just on that specific thing, like, grab us and we'll pull the product team, we'll do an NDA deep dive. We'll make it happen.
All of you. That's for all of you.
Yeah,
or I'll buy cocktails and get me drunk enough and I'll just tell you.
Tell you what, just...
All right. So I think that wraps it up. I'd like to thank the panel for a great hour.
Thank you, everybody.
Yeah, thank you, guys.
A couple last things. One, you know, please make sure you guys follow us on Twitter and all the other social media sites. Don't be shy. Ask your questions.
Session feedback too.
Yeah, talk to us in the halls. And then most importantly, session feedback is great because that's how we're able to do this every year. So make sure you review. And with that, enjoy the rest of the week here in San Francisco, and we'll see you next year in Vegas.
Woohoo!
Sounds great.